In this video, we are going to look at Unit 7, Lesson 12, which is about radian sense. So by the end of this lesson, you're going to be able to be given a bunch of different angles in degrees and radians and be able to order them from least to greatest. This lesson starts on page 226 with a which one does not belong. So go ahead and determine which one of these, in your opinion, doesn't belong and why. And then we will talk about them when you come back. All right, so you could have a variety of reasons why you choose that different ones don't belong, as long as you can back them up. And so this first one, maybe you decided that A doesn't belong because it's the only one that didn't have the angle measure labeled in the angle. You could figure out the angle measure by doing arc length divided by radius and get that this is a pi over 2 angle, but it was not directly given to you. B, maybe you decided this is the only one that's more than a fourth of the circle or more than 90 degrees. C, maybe you noticed or realized and said this one didn't belong because it's the only one measured in degrees. And then maybe for part D, you decided this one doesn't belong because it's the only one with a whole number. All right, then in 12.2, if you're in class, you're going to work with your small group to fill in these blanks down here under this double number line on page 227. If you're working alone, you can certainly do it yourself. So you just want to get these blanks here filled in with the radian measures. So think back to lesson 11 and see if you can fill in the radian measures. Once you've completed that, questions 1 and 2 ask you to try to come up with how many degrees are these radians and how many radians are these degrees. After you've worked for a little bit, come back to the video and we'll talk through it. All right, so coming up with the radian measures, so we know 0 degrees and 0 radians would be the same. Okay, maybe you remember that the whole the top half of the circle was pi radians and the entire circle was 2 pi radians. So that gave you a couple anchor points. Then when you're looking at 90, 90 is halfway between 0 and 180. So this radian is going to be halfway between 0 and pi, or half of pi. And then same thing here, 270 is halfway between 180 and 360. So we're going to be halfway between 1 and 2, which is 1.5, whereas a fraction, 3 pi over 2. So we've got 1 pi over 2. This would really be 2 pi over 2, which simplifies to 1, 3 pi over 2, and 4 pi over 2s, which simplifies to 2. So that gives you a little bit, and actually I'm going to leave those on there just in case you want to look at them. 1 as a fraction and 2 as a fraction. So for pi over 3 radians, how many degrees would that be? And so you certainly could realize that you're taking this pi here and splitting it into 3 equal parts. So you want to do a similar thing to 180. So divide 80 into thirds. So 180 divided by 3 gave us 60 degrees for that angle. And then 5 pi over 4. So pi over 4 is half of pi over 2. So pi over 4 would be halfway in between here. And halfway in between 0 and 90 would be 45. And then we want 5 of them. Okay, so 5 pi over 4. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, or 5 of these 45s. Okay, so then you're getting 45 times 5, and that would give you 225 for your degree measure. Degrees to radians, so 30 degrees, where would 30 degrees fall on here? So 30 degrees would be here. It's actually 1/3 of 90, right? 30, 60, 90. Okay, so it's 1/3 of that. So you could think of 1/3 of pi over 2. Okay, or dividing pi over 2 by 3, splitting pi over 2 into 3 parts, which would be pi over 6. You can also think of how many times 30 would fit into 180. Okay, so 30 goes into 180, would split the 180. By 30, would split the 180 6 times. So it's going to split the pi 6 times. So pi divided by 6. And then 120, multiple ways you could think of this. Now that you know that 30 is pi over 6, and let me just also write this circle here. Okay, so we know that 30 is pi over 6, so it's splitting this kind of pi into 6 slices. So we know that's pi, or 180 degrees. So here's our 30 degree chunk. How many times does 30 go into 120? So 30 goes into 120 4 times. 30, 60, 90, 120. Each of these being a pi over 6. So now we would have 4 pi over 6s for 120, which would then simplify, both would divide by 2, so we'd end up with 2 pi over 3. So another way to think about that is that 60, let me get this drawn back on here. So 60 we could have thought of as going into 183 times. So we can kind of see here, these are each 60 degree angles. So if this is 60, this is 60. Okay, there's 2 of these. And they're 2 pi over 3s. Since this is pi split into 3 chunks, each of these are a pi over 3. And we saw that here as well. Okay, so then this would be 2 pi over 3s. So definitely multiple ways to get yourself there. Depends on what one you like and which one feels best to you. So how many degrees would pi over 12 radians be equal to? And how do you know? How many radians is 1 degree equivalent to? How could you find the degree angle measure equivalent to 1 radian? So decide if you can answer those questions and then come back to the video. Well, in the last one, we figured out that pi over 6, okay, is equal to 30 degrees. So pi over 12 is half of that. Okay, so pi over 12 is half of pi over 6. So it's going to be half of 30 as well. So pi over 12 is going to equal 15 degrees. You could also take pi in degrees. Okay, so if we know that pi equals 180 degrees, we could just divide each of these by 12 as well. And then you would end up with pi over 12, or 180 divided by 12, which is 15 degrees. How many radians is 1 degree equivalent to? Well, how many, you can look at this a couple different ways. You could remember how many degrees are in pi. So there's 180 degrees here. So we'd have to split this into 180 equivalent pieces. So pi divided by 180 would equal 1 degree. You could think about it that way. Maybe you like to remember how much the whole circle is in radians. So this whole circle in radians is 2 pi. So we'd be taking all of these 2 pi radians and dividing it by 360. That would also get us what 1 degree is. And again, if we wanted to leave this in fraction form, we could divide each of these by 2. And it would simplify down to that pi over 180. And then the decimal version of this, so if you actually typed in pi and divided it by 180 in your calculator, you'd get every degree is equal to 0.017 radians. So that's kind of the decimal version of it. how could you find the degree angle measure equivalent to 1 radian? So how could we find the degree angle equivalent to 1 radian? So for this, if you're thinking about proportionality or proportional reasoning here, we could think about that we know that pi and 180 are equivalent. So we could be saying, all right, and we need the degree measure here with 1 radian. So you could set it up that way. You could think of it as part to whole. So 1 radian compared to pi radians is going to equal how many degrees to 180 degrees? And then you could solve that way. And so if we end up cross multiplying here in either case, you're going to end up with 180 times 1, and then pi times x, and then divide by pi. So 1 radian would equal 180 divided by pi degrees. And you could also think about the fact that, you know, you've got pi radians here and 180 degrees. So now we need to split 180 degrees into pi equal chunks. And that would be this same idea here. So then you could do 180 divided by pi. And if you want to think about it as a decimal, so this is equal to 1 radian in degrees is equal to 57.3 degrees. So 1 radian in degrees is 57.3, so just under 60 degrees. All right, then this next one, if you're doing the lesson at home, you won't really be able to do this because you need to have cards, but if you're in class, you'll need to make sure that you get the cards from your teacher. And this starts on page 228, and you'll see 2 big circles there. And what you're going to do is you're going to draw a central angle card from the stack that your teachers gave you. You're going to shade in a slice with that central angle on whichever circle you choose. And if you need to, you can add more lines to break these angles up further. You need to take turns with your partner, and you need to stop once the card that you draw, you can't fit it in here without overlapping other angles. Okay, so the goal is to not overlap angles. And once that happens, then you need to answer the questions on page 228. So we're going to do an example here before you go try this. So here would be a card that you're going to get, like a pi over 3 angle. So then you need to go and find a pi over 3 angle in either of these circles. Okay, so I don't see anything that's split. So I remember that the diameter kind of splits the circle into pi radians. Okay, and I don't see this being split into 3 equal parts directly, but I see that this one is 6 equal parts. So I could go here, and this would be 1/3, because if I did this, 3 equal parts. So I'm just going to shade in 1/3 of this. Okay, so I'm going to shade in this part. So 2 1/6 equals 1/3. All right, so then you're just going to keep drawing different central angles and shading in until you draw a card that doesn't fit on your circle anymore. Then come back to the video. All right, so let's look at kind of how you would have, especially if you can't do this activity at home. Here's some of the angles that you would have gotten if you were drawing cards here. So let's take a look at how you would have shaded these. And so if we have a pi over 4 angle, we can certainly see a set of angles on here that splits pi into fourths. So this would be a pi over 4 angle, because it's splitting this half of the circle into 4 equal parts. So there would be a pi over 4 slice. And pi over 6, then we see over in this kind of larger circle. And that one, because they're taking the diameter, splitting it into 6 equal parts. So one of these little ones would be equal to a pi over 6. Pi over 3 we talked about on the last screen. Pi over 3 would be 2 pi over 6s. Okay, so we could just shade in 2 of these. So 2 pi over 6s equals 1 pi over 3. So there's our pi over 6 angle. And then pi over 2. So thinking about, you could do this in whichever circle you needed to, because we can certainly do this in any. So pi over 2 would be taking half the circle and dividing it in half. So we've got pi here, and we would want to do this. So whichever circle you kind of feel like you want to do that, because remember the goal had been to try to fill up as much of the circle as you can. So depending on when you had gotten that, when you'd drawn that one. So I'm just going to draw it in here. Oops, wrong color. And that's going to be, you could have done it here. Okay, or you could have done it here. This one just would have had 3 in it. So let me just kind of highlight 3, 3/6 being 1/4. But so we could have colored in there. I'm going to stop coloring them in. And then pi over 8. Now pi over 8, you need to have something divided into 8 chunks. So we would need to split one of these up a little bit more, because we have divided into 6ths here, or 12ths of the whole circle. Here we have 4ths for pi, 1/8 of the whole circle, but we want to be looking at pi. So if I'm doing pi, if I'm splitting up pi into 8ths, I want this chunk to be split into 8ths. Well, I have it in 4s, so I would want to split these angles in half, or one of them, so that I could get to a pi over 8. So if you just split one of these angles in half, that will give you your pi over 8. And then pi over 12, kind of the same idea. You've got 1/6 pi here. So if you need to get 1/12 pi, you can just split one of these 6ths in half. So if you just did one of the 6ths in half, then you'd have a 12th. So then that angle there would have been a 12th. So the answers that the questions that you were supposed to answer in your book had to do with how much of the central angle is remaining for your unshaded portion. So let's just take a look at a couple examples of something that you maybe could have had. So maybe you had shaded kind of this whole thing here in this circle. So your shaded, okay, is 1, 2, 3, 4, 5, 6, 7 pi over 4s. And your unshaded is 1 pi over 4. And we could look at, maybe you kind of got this one split extra here. Okay, and then maybe you shaded all the rest of this. Okay, you shaded everything except for that really like little slice there, and we had split it in half. So those were pi over 6s. So this little slice here is a pi over 12 that's left. Okay, so maybe your shaded was 23 pi over 4s, because there's 12 on top, 12 on bottom, and you're missing 1. And that unshaded was 1 pi over 12. Okay, maybe you had split one of these in half for an 1/8. Okay, and maybe you got shaded to here. So shaded versus unshaded. So we had this as an 1/8. This is 2/8. So you have 3 pi over 8 unshaded. And shaded, okay, you have 2, 4, 6, 8, 10, 12, 13 pi over 8 shaded. Since there's 16 total, you've shaded 13 of them. So those are just some ideas of what it could have come up with if you were in class. So go ahead, look at this screen, decide which one is larger or smaller and how you know. You don't have to actually like calculate anything necessarily, but just try to think which one's bigger or smaller and why. So for this first one, 200 is larger because it's more than halfway around the circle. We know that pi is halfway. So pi is halfway around the circle. Okay, 200 is more because this would be like 180. So 200 is going to be further than that. 3 pi over 2 versus 200. 3 pi over 2 is 3/4 of the way around the circle. And we know that matches with 270. So 3 pi over 2 is larger. 1 radian or 90 degrees. Well, 90 cuts half the circle in half, right? So it's 1/4 of the circle. But we know that just over 3 radians fit in the top. So we know that 1 radian is going to be over here, smaller than 90. And then pi over 3 versus 45. Well, we know that 45 is 1/4 of the top, and pi over 3 is 1/3 of the top. So we know that this is going to be the larger angle. So here's your lesson summary. We talked about dividing the circle into congruent sectors to talk about radians versus degrees. And so if we had divided the central angle of pi, so half the circle, into thirds, we know that each of those is 1/3 pi for the radian. So this shaded section has 2 of them, so 2/3 pi, or 2 pi over 3. We also took a look at putting them together on a number line, so thinking about dividing them into equal parts to come up with equivalent portions. So if we needed to know the size of 3/4, 3 pi over 4, we could take pi, divide it into fourths, and look at 3 of them, and then do the same with 180. So if I wanted to draw this out here to show you, so if we cut these in half and half again, that would be fourths. So same thing here. And so we would want 3/4 pi. So if you cut this in half, that'd be 90. Cut it in half again would be 45. 90 plus 45 is 135. So 3/4 pi would be equivalent to 135 degrees. So here's your cool down for the lesson. Be sure if you are struggling with this that you make sure to reach out to your teacher for help.